I go by Bob. The company is BAU Hopkins. We're located in just outside of Foxborough. Been in the industry since the 80s, so we've been around for a long time. We specialize in chemical feed applications. If you get nothing out of the training other than my phone number, 90% of the time, if you can walk me through an issue on the phone, I can walk you through how to fix it on the phone.
Okay.
There's nothing super challenging about these pumps. They're pretty straightforward. So my first question before I get into the whole big spiel, have you guys used peristaltic pumps before?
No,
Okay.
I have.
Are you familiar with peristaltic technology? No. I'm gonna make this very, very simple. When you go out there, you're gonna see a bunch of, we love to call them square boxes. And you're gonna have a suction line coming in and a discharge line going out. So from your tank, your gravity filling into the pump, and then the pump, the box, is doing its magic to pump out into the process. A peristaltic pump uses what they call a roller assembly and a tube. So when you come in here, there's a process tube that runs this way in there. So the product comes in, goes through the tube. This roller is basically spinning in this direction, right? So it's spinning around, and we're basically squeezing the tube, pushing the product over and out.
Toothpaste.
Exactly, 100%. What makes this style pump different than a lot of the other ones, the chemical is actually on the inside of this tubing. Other style pumps that they call diaphragm pumps, like the chemical is coming through the head and you have basically a diaphragm that pushes back and forth, and the chemical is basically inside the pump head. So it's coming from the bottom and going out the top. This is just basically a roller. The feed rate of this pump is determined by two things. Most importantly, the inside diameter of this tube, which has already been pre-selected for your applications. So if you imagine a tube that's about a 1/4 inch thick, you can only get X amount of product through it. If you wanted to increase capacity with the same style pump, you can put a bigger style tube in. And then two, how fast you run this roller. The roller is 0 to 125 revolutions per minute. If you run it at 125 revolutions per minute, you're going to be calling me every 3 months or so to be getting new tubes. Pump is not designed to run continuously at max speed. It'd be like getting in your car, hitting the gas and doing 180 miles an hour just 24/7, right? Eventually you're going to crash into something or the car's going to break down. On the pump itself, you have the roller. There's a shaft that this roller sits on. And then there's a cover that sits on the front that has 4 little thumb screws. There's right on this corner of the front, there's a magnet on the inside of the cover. As soon as you take that cover off, the pump knows that the cover's been removed and it goes into maintenance mode. So even though you're in maintenance mode, the cover's off, you walked up and manually hit the start button, this roller will only run at 3 RPM. It will not allow the pump to run at full speed. You basically hit the start button, this roller will start rolling at 3 RPM, pull the tube out using the roller to assist you. When it goes in, there's little slots that the tube actually sits in. You basically rolling it around and then snugging it in. The roller slides off this shaft, slides off towards you. This shaft is splined, so it has a flat edge on it. The roller can only go on in one orientation. And the roller itself actually is labeled front and rear. If you put the roller on backwards, the back side of it has a little bit of a recess which sits on the back side of the shaft. The cover will fit snug. If you flip the roller around without reading it and put it back in, it won't snug all the way back in, so when you go to put the cover on it, there's about an 1/8 of an inch gap that you can't get the cover down. I've seen people put channel locks on that, crank it down and just shatter the acrylic cover. Please don't use any tools on this pump, everything's hand tight. Inside here, the roller's rolling, you have your tubing. If the tubing that's here, if this was to rupture, down on the bottom on the inside of the pump is a little conductivity probe. If the product is allowed to go down, bridges the conductivity probe, it'll go into an alarm basically saying, hey, I've gone into a tube failure. Go out there, you obviously change the tube, isolate the chemical, change the tube. Don't use any type of abrasive on these 2 little pins. It's a conductivity probe, so if you go in there with an abrasive or anything and you file off the end of those, you're going to change the way the conductivity probe works. As this is rolling, you're basically squeezing the product in and out. 2 things that will shorten the life of this tube, how fast you run this, and then also where you're pumping it to, what type of back pressure you have up here. If I was pumping, say 100 PSI, I have all that pressure coming back this way towards the pump. In addition to that, I have the pump turning and trying to push pressure. Sure, backwards here. So I'm counterimposing, right? So as this roller is going around and squeezing forward, it's trying to push fluid out as well as trying to contradict the pressure coming back at you. So in the piping system, we put a valve on the discharge side. I'm a really bad juror, so we're just going to call this a back pressure valve. BPV, right? So this back pressure valve is an anti-siphon valve. So it's not a bi-directional flow valve. So even though you have 100 pounds of pressure here, on this side of it, we set it to a different pressure. So like in your example out there, you have pretty much open-ended back pressure injection points. So we have these set to 30 psi. 30 psi is the most pressure that this is going to be seeing right here. So as you turn this down at a slower rate, your counter forces are not as great. 99% of the time when the tube breaks, it's going to break right at this point, right on the discharge side. These are connected, this here and here. They have quick connect fittings. So basically it's like this, and you lock them in place and you pop them up. What's nice about that is you get a call in the middle of the night. You don't have to worry about like cracking a union threads or anything like that. You just pop it in, pop it off. The tube comes as an assembly with the other side of the quick connect to it. So all you do is basically put a new tube in, pop it back into place, prime the pump, and away you go. You don't have to worry about priming the pump because there's no ball check, so it's basically self-priming by nature of the pump. Majority of the time, this is the top that controls. There's a screen on the top, and there's basically an on-off push button. But this is an LCD screen, which we have set up so when you turn it on, it reads in gallons per hour. 90% of the applications are gallons per hour. If you want it to read in liters per minute, we can do that. So when this is running, you'll have the start-stop. You'll see that this is running at, 10 gallons an hour, and you're pumping. The functionality of the pump is going to be left probably in the remote mode, I would say majority of the time. So we're going to have this in remote, and then 4 to 20 for your speed signal. And basically those two features are, you have a remote start-stop and then a speed command. So I tell people this is like getting into your vehicle, right? You get into your car, turn the key on, now you've started the car is ready to go, and then when you step on the gas, it basically goes as fast as you step on the gas. So 4 to 20 is your flow pacing signal, telling the pump how fast to run, and then your start-stop is telling the pump to turn on, turn off. Pump has 4 to 20 output feedback to SCADA system, so if you're sending it a 50 milliamp signal or a 12 milliamp signal for 50%, you're going to be seeing 12 milliamp signal, 50% speed feedback. It also has the default for the leak detection, so if at any time you have a leak in there, you'll trigger the leak detection and shut the pump off. In addition to, on the piping side of things, in addition to the back pressure valve, downstream, so as you go past the back pressure valve, there's another valve in place. This is a pressure relief valve. So think about this pump, you're operating it off a SCADA system. It's a dumb piece of machine. You're sitting in your truck off the side of the highway, you turn this pump on. It has no idea if all the valving is open. So if you start pumping this pump and you have a valve down here that's closed, this pump won't know it. It's just going to keep running. This pressure relief valve is set to open and recirculate the flow to protect the pump from self-destructing. So right now, the back pressure valves are set at 30 psi. Pressure reliefs are set at 50 psi. So anything over 50 psi, this valve will open and start to recirculate. On the pumps itself, when this relieves, it has a relief line. On 3 of the skid systems, there's a clear sight glass, so you can actually see the product. The downside with this is, depending on the product that you're pumping, you might not be able to tell if it's actually in there because of the opaque color of the glass. If it's sodium hydroxide, you're going to have a hard time seeing it. Citric acid, you'll probably see a little bit of a colored in it. And the hypo, depending on the strength of the hypo, you'll see a little bit of a tinge of green in it. Micro C, good luck. Yep. So basically, all this is contained on a skid system that we as a company provided. So anything on that skid system that fails within a year, you'd be calling me to come back and warranty it. Most of these, once you get past these 2 valves on the skid, it goes up and out, and it's open-ended where it's going. I think the only ones that are going into the feed system are the MBR. There's 2 pump systems down there. So the citric acid and then chlorine, I think, right? Also, tubing material. Even though all the tubes look the same, so when we go out there and tube clips into these, there's a code on the end of that tube. Yep. And it'll be like a NNJ. That's a material code. So not all tubes can be used on all chemicals. So you'll find out real quick if you put the wrong tube in, it'll just eat right through it. That'll all be documented. You guys will have somewhere along there's O&M manuals that exact numbers in there as far as replacement pots and so forth. If you do have a chemical leak, depending on the severity of the leak. So when we go out there, I'll show you like where this cover sits over these tube fittings. There is a little bit of a gap. So as product, say it's on a weekend or a holiday break and product's allowed to continue to fill the pump, it'll only get to about this bottom portion before it starts to weep out. For whatever reason, the pump doesn't shut off, or you try to override the alarm and you get chemical up into the roller assembly. The roller itself has stainless pins that keep the roller in place. So if you get like sodium hydroxide or hypo crystals inside there, you could bind those. Yep. So it's always, if you do have a leak, take this out, run it under hot water, make sure there's no chemical in the roller assembly, and then put the roller assembly back in. On the shaft, there is a guide, a wear washer
Yep.
on the front cover and on the back. Make sure those washers are in there, because that roller assembly is allowed to kind of move freely in there, just in case you do get some resistance in there, that roller is not fixed and it's not going to start to bind on the tubing. If you do take this apart and you see tubing shavings on the bottom, 9 out of 10 times that means one of your rollers are starting to stick. And instead of rolling, it's dragging.
Yep.
And you're dragging basically the outside of the tubing off, like kind of like sharing it off the top. And eventually, if you share enough of it, you're going to get a pinhole leak in it and it's going to leak inside the pump.
Does the shaft need to be lithium grease or anything like that?
I would recommend putting grease on that shaft. Food grade grease,
Yeah.
because you're dealing with chemicals. And even though you're on a wastewater side of things, trying to find a compatible grease with hypochlorite and caustic, usually food grade is a lot more compatible than trying to find something else. A little bit more expensive, but it'll last a little longer.
Rollers or anything, they don't contract or expand. You just leave it on there and feed it around. Rollers you can actually retract, so it's easier to get the tubing on there.
Yeah, no, these
They stay fixed, and
Yeah.
you just use the motion.
Yeah, but I will tell you, like some of the most common failures that we see with these. This is an LCD display. This goes for any chemical metering pump, right? The compatibility of the pump is designed to have the chemical on the inside of the tubing in the pump head. It's not meant to have chemical on the outside. So if you do have a leak, try to be like housekeeping, try to clean it up. It's a plastic, it's a Hemophorex plastic housing. I will tell you firsthand, sodium hypochlorite will shoot through that faster than anybody's business. Even though it's IP66, I could take that and throw it in your lagoon and it would be fine. You put hypo on it and it's not fine. So the display, sometimes the display will get funky. So it's like your iPhones, a touch issue with the display if you get chemical underneath it. And then also too is if you're running them at high speeds, but some of the bigger ones like the citric acid and your hypo ones, those are 100-gallon-an-hour pumps. If you run those at 100 gallons an hour, that thing really starts to rock and roll. The front cover assembly will start to shake. These will come loose, the bolts, those little thumb, and that magnet will disengage and it'll go into a pump maintenance mode. If you have those issues, just try to tighten down the thumb screws first. And obviously if you've got any type of chemical on that magnet, it won't recognize the magnet back and forth. But other than that, these things are bulletproof. Just one last note as far as maintenance on it. If you're not going to run the pumps, like say for example your citric acid skid, and I'm just going on a limb here, right? Like one's going to be lead, one's lag, like standby, or you're going to alternate them one day. If you run citric acid through the pump and you're not going to run citric acid for another 6 months, do yourself a favor and flush this out, because I'll guarantee you if you leave citric acid in there, it's going to find a way to leak. And then when you go to use the pump, it's not going to run. And then you're going to call me up and say, hey, this thing sucks and I can't get it to pump. And I'm going to come down and this tube's going to be solidified to the point where this roller can't squeeze anything. The system has calibration columns on it for testing purposes. They have funnel tops on them, so you can just walk up to the top of the calibration column, dump some water into it, isolate your tank and pump the calibration column down with the water until you flush the chemical out of it.